This is a quick summary of how to handle force problems in physics using Newton's second law. Here we have a box, and this box has a mass of 10 kilograms. It's resting on a frictionless surface, that's the surface, and there's a push of 100 newtons placed on it at a downward angle of 30 degrees. So the question that we have is, what will the acceleration of the box be? What we want to do is treat the box as if it's a point mass, and so I'll draw a point representing that mass, and then I want to do a free body diagram, which is a summary of all the forces acting on the box. So we have our weight, which is mg. M is 10 kilograms, g equals 9.8, so the weight is 98 newtons. Okay. We also have a normal force that is the surface pushing up on the box in response to weight and other things that are going on. And then lastly we have a 100 Newton force acting at 30 degrees. So the question is, how do we solve this? Well, first of all, just like in kinematics, we don't do things that are off axis. So I want to replace this vector here that is off axis with its components. We do that just like we did previously with velocity vectors. So the x component is equal to 100 newtons times the cosine of 30, which is 86.7 newtons. In the y direction, it's the sine, so 100 newtons times the sine of 30, that equals 50 newtons. So what I'm going to do is replace this one vector by two of its components. So I'm going to erase this just to help us keep track. I'm going to put my components in blue here. One is fx, one is fy. Okay, now I'm ready to apply Newton's second law here to both the x and the y direction. So let's work on the y direction first. We're going to rewrite this equation as f net y equals may. Now in the y direction, the box does not go up or down, so we know the right side of this equals 0. There's no acceleration of the box up or down. On the left side, we're going to put all of the forces acting on the box vertically, and we'll use a plus if it's in the positive y direction upwards, and a negative if it's in the negative. So we have the normal force N minus Fy minus W equals 0. So N equals Fy plus W. Fy is 50, the weight is 98, so this is 148 newtons. So the normal force is more than the weight because the external push on the box has a component that pushes downward. We'll also do F net in the x direction, and in the x direction there is acceleration. So the only force is f of x equals max. We know f of x, which is 86.7 newtons. We know the mass is 10 kilograms, so I can solve a of x equals f of x divided by m, which is 8.67 meters per second squared. So this procedure that we've taken is going to be used on every problem in Chapter 4 and 5. We're going to size up the situation. We're going to take components of any vectors that are off of the x and y axis. We're going to then use Newton's second law in the y direction and second law used in the x direction, add them up and figure out what's going to happen.